All right, it's 12:3 surface area of pyramids and cones. Let's do it. So, first thing we got to talk about is what's a pyramid. I think we talked about this quite a bit in the first section, but a pyramid has one base. That could be any polygon. In this case, it looks like a square. And then it's got lateral faces, which are triangles that meet at a top vertex. The triangles are known as lateral faces. The edges of the triangles are the lateral edges. The bases of the edges of the base are the base edges. But there's some different things here with the height. So the distance from the vertex straight down to the base is the height or the altitude. But then if you slide down one of the sides, one of the lateral faces, the height of each triangle is known as the slant height. And what we're going to use for the height, the altitude, we're going to use an H. For the slant height, we're going to use this cursive lowercase l to represent it. So yeah, there it is. The slant height is a cursive lowercase l, and it's the height of each lateral face. To find the lateral area of a pyramid, well, we're going to want to find the sum of all these triangles. So if we think about this, let me move this out of the way a little bit here. What if I even do this? There we go. If I think of each triangle and I wanted to find the area of each of those, I would do, well, they're triangles, so I'd do half base times height. And then I'd multiply it by how many there are. In this case, since it's a hexagonal or hexagonal pyramid, there's 6 base edges, which makes 6 lateral faces. So I do 6 times the half base times height. Well, the base of each triangle is the side length of the base. And those, in this case, those 6 S's, well, that's just the perimeter of the base. The half, well, the half's going to stay a half. And then the height of each triangle, we said is called the slant height. Half perimeter slant height. And that's going to be our formula for the lateral area of any pyramid. Half perimeter slant height. That'll give you the sum of the lateral faces, which are triangles, in any pyramid, the sum of the areas. So the lateral area of a pyramid, again, I use LA, is half perimeter of the base times the slant height. So we can find the lateral area of a square pyramid with a base edge of 14 and a height of 24. Find the lateral area of a square pyramid with a base edge of 14 and a height of 24. Let's start by drawing it. I highly recommend when drawing a pyramid, even though the base is a square, you don't want to draw a square like you're looking at it from the top or the bottom. You want to make it look a little three-dimensional. So I recommend kind of like a flat parallelogram or rhombus. And if you do that, pick a point right on top and just connect each vertex of the base to the vertex on the top that you selected. And I should try that again. Even just doing that. I should be using my straight line tool. I don't know why I'm not. There's a really terrible version of a pyramid. Maybe we'll even do it one more time using some better tools. Is this working? Not even really working properly, but ooh. All right, we'll take that. They're saying that the base edge is 14. So since it's a square, I know they're all 14. And it's saying the height, not the slant height, but the height is 14. That's the altitude. That is the perpendicular distance from this vertex up top to the base. That is 24 centimeters. They want to know the lateral area. So what we talked about doing on the first slide was taking half perimeter slant height. Problem, I don't know what the slant height is. So we need to find it. And I'm going to give you a little hint. We could make a right triangle here. I could use this segment here, which I'm going to draw the square from a bird's eye view. If I have a side like the 14, what I need is the line that comes from this center to the base edge. That's this. What would that be called in a square? If you said apothem, you're absolutely correct. That is the apothem of the square. So I could draw the triangle and find the apothem using 45, 45, 90, and maybe I will. 360 divided by 4 is 90, which makes this a 45, 45, 90, which makes this 7. So the apothem is 7. Or we could just use the little trick that in a square, the apothem, it's just half the side. It's that same distance right there. It's half the side. So I have an apothem of 7. And if you take a look at what we got here is a right triangle. The apothem, the height, and this slant height here are forming a right triangle. The apothem squared plus the altitude squared equals the slant height squared. That's one of the right triangles that you'll be using relatively often. I don't know if I did a great job here, but that is our right triangle we're going to use. And I happen to know that if half of 14 is 7 and the height's 24, that 7, 24, 25 is a Pythagorean triple. Just another great use of your Pythagorean triples that we talked about. So when I'm doing half perimeter slant height, I just figured out that my slant height must be 25 because Pythagorean theorem. The height is 24. I'm sorry, I'm doing half perimeter slant height, so I need the perimeter, which is 14 times 4, or 56, and it's half times 56 times 25, and let's see, half of 56 is 28 times 25 is 700 square centimeters. And all we've just found is the sum of the lateral faces of the pyramid. So now, if we are going to find the surface area, well, we just have one side to add, the one base, which is why the surface area, total surface area, is the lateral area plus the area of one base. There is only one base in a pyramid, which is why you're only adding one b. So our surface area, we're going to take our lateral area, which is 700, and we're going to add the area of the base. And if you remember what it was from the last slide, the base was just a square with a side length of 14. So 14 times 14, I'm going to do 700 plus 14 squared, which is 196. And I get a total surface area of 896, and it was centimeters squared. So once again, our lateral area of a pyramid is half perimeter slant height, and our surface area is half perimeter slant height, or lateral area, plus the area of one base, where that one base can be any polygon. Any polygon area. So that will, this letter B is kind of all of the last chapter rolled into one. Let's see what you can do here. Let's find the total surface area of this regular pyramid. It looks to be a pentagonal pyramid. Give it a shot. All right, see how you did. I'm going to start, well, I'm going to just go right. Surface area equals half perimeter slant height plus area of the base. So I got my half. I've got my slant height. They gave it to me. That's nice. That's a 17. I need to find the perimeter of the base. Some issues. I don't have any sides of this base. It is a regular pentagon. Give myself a little sketch to draw to deal with. I don't have anything, but what I could do is find the apothem using that same right triangle. Don't forget, apothem squared plus height squared equals slant height squared. So I have a blank 15, 17. We can use our triples once again, 8, 15, 17, to figure out that the apothem is 8. Once you have that apothem of 8, we could go ahead and find the perimeter by finding the half side. I'll solve for x. 360 divided by 5 is 72. Cut that in half, and I get a 36-degree angle there. And to find my half side, I would do tan of 36 equals opposite over adjacent. My half side is 8 tan 36, which makes 16 tan 36 my full side, which makes the perimeter 5 times that, or 80 tan 36. So I'm going to do, just going to squeeze that in, 80 tan 36 plus the area of the base. Well, now I still have some work to do there because the area of the base is going to be half perimeter, 80 tan 36, times the apothem, 8. So I'm going to do 4 times 80. So the area of the base is going to be 320 tan 36. So I'm going to find my lateral area by doing half times 17 times 80 tan 36. Let me get that calculator back over here. Here we go. So what was I saying? I am going to do the lateral area, which is half of 17 times 80 tan 36. I'm going to do 40 times tan 36. That's half of 80 tan 36. I'm going to multiply that by close parentheses. Where's that close parentheses? What's my problem here? Okay, I guess I'm just going to hit enter. There's my 40 tan 36, and I'm going to multiply that times 17. Answer times 17. Nope, that's not 17. Wait, 17 times, sorry, I'm having some issues. 40, 10, 36, that works. This 494 represents my lateral area, and then I'm going to add 320 tan 36. So maybe struggling with this here. Aha, there was my parentheses all along. All right, so the 670, let's see. This 494 represents my lateral area, and I guess I can write that in. 494 point whatever plus 320 tan 36. So I'm going to go answer plus 320 tan 36. And my total, 726 is what that said. I'm just going to get my total there, 726.54. There's my total surface area. I never actually found the area of this 320 tan 36. 320 tan 36, just for those of you who are really trying to follow along. That was 0.5, and then I could add those together to get about 726.5. And of course, it's inches squared because it's surface area. So the 494 represents the 5 triangles, lateral faces, and the 232 represents the area of the pentagonal base. And when I add them together, I get the total surface area of about 726.5 squared inches. A cone, just like we talked about, prisms and cylinders are the same shape, but just the cylinder is a circle. Well, a cone is just a pyramid with a circular base. So to find lateral area, I can stick with my half perimeter slant height formula. Just realize that the perimeter is always going to be of a circle. So when I'm doing it, I could just change the perimeter to 2 pi r for circumference and multiply that by the slant height. And then the half and the 2 cancel out, and I'm just left with pi rl. And that's my lateral area. For the surface area, I take my pi rl, lateral area, and I add the area of the base. Since the base is always a circle, I could just write pi r squared, and this becomes your surface area of a cone formula. But as someone who doesn't love to memorize a million different things, I just stick with my pyramid formula and just edit it to be a cone by plugging in, circle for the circumference and area of bases. So let's try one. There's our formula as written by the textbook. Again, they're using T for total area. I generally use S or SA for surface area. Yeah, let's start by finding the lateral area. Go ahead. All right, that shouldn't have taken too long because it's just pi RL, or half perimeter slant height. Don't forget those cancel, leaving you pi RL. So it's pi times the radius of 8 times, I don't have my slant height, but I can find it very easily by just realizing that this is a 45, 45, 90. Perfect. You could also use Pythagorean theorem, and I get 64 pi root 2 inches squared, and that is our lateral area. Hope you got that too. We could also find the surface area. Yeah, let's go ahead. The surface area, well, I take that 64 pi root 2 and I add the area of the base. Well, area of the base is pi r squared. Don't forget, because it's a circle. So I get 64 pi, and I would just leave it. Sometimes you'll see it written the other way where they'll put the root 2 at the end. You cannot combine those. They're not like terms. It's 64 pi plus 64 pi root 2 inches squared. And that's going to cover your pyramids and cones. 12-3. I hope to see you at the lab lesson.